CBRD. Over to you, Russell.
Thank you very much, Marcy. And a special thanks to all of you, the members of the public that are joining us here tonight. First, I wish to acknowledge that we are on the traditional unceded territory of the Comox First Nation. And the Comox First Nation is a very important partner of the Comox Valley Regional District. They have been very engaged with us in this process. We continue to communicate with them, and they continue to provide their input with respect to conveyance and the broader issues we're facing through the Liquid Waste Management Plan. I really, again, wish to acknowledge your participation and to recognize that this Zoom meeting is absolutely a great opportunity. Not only do we get to engage with you in your homes when we are all safe, but through the recording, we make this available to the public. So if there are members of your community that want to see the results of this, it will be available on our website. Also, another advantage is your questions. We share your questions, the answers are shared. Open houses are great opportunities, and we've performed those, but this is even greater in terms of the ability to share the answers and the response to your questions and concerns. So thanks for participating in this format. Groundwater is incredibly important to us, and Chris LaRose will address some of the issues and be available to answer your questions. Groundwater is so important that in the very beginning, we engaged Gilles Wendling, a very qualified hydrogeologist and specialist in this area, to help inform us as how we can respond to your concerns and issues moving forward, that we can make this project work. The Liquid Waste Management Plan and conveyance is so important to the Comox Valley. Yes, while principally the service serves the city of Courtenay and the town of Comox and Comox First Nation, it is there for all of us. It serves our hospital, our schools. The treatment works provide an opportunity for septic to be treated for our rural residents in order that they maintain their septic systems. So it is very important to us all. As we've mentioned, groundwater is also important. We realize that in order to fix the problems with respect to the Willamar Bluff and ensure that we can protect the environment, there needs to be an alternative in terms of conveying water to the treatment works. So your input tonight will be important for us to shape and ensure that we provide the best solution. Again, I wish to thank you for your participation. Chris will lead you through some information. We will all be there available to answer your questions and hear your concerns. Thank you.
Okay, Chris, over to you.
Great. Well, thanks for that excellent setup, Marcy, and the thorough introduction, Russell. And good evening, everyone. Marcy, will you pull up the presentation?
Yes.
There you go. Yeah, so I'm very happy to be here with you this afternoon to discuss our project and try to ease at least some of the concerns that you have about a sewer line crossing your neighborhood, and specifically about the risk of accidental contamination of drinking water. So thank you to those that have provided questions in advance. I've done my best to incorporate answers to those into the presentation. And then after the presentation, as Marcy and Russell have highlighted, we'll all be available to answer any other questions that are unresolved or triggered by the information that I'm going to present to you shortly. So I'll start with a description of the process that we are working our way through, and then describe the project in greater detail and what we're doing specifically to mitigate risk to drinking water. So the liquid waste management planning process is a provincially governed process that's made available to municipalities and local governments as a tool to help plan for the future of their wastewater systems. So working under the guideline established by the province, the municipalities and local governments walk through a process that culminates in a plan that's submitted to the province for review. So we initiated our planning process in early or mid 2018. And since then, actually, so part of the initiation of that was, so there's a public engagement program, but also formation of a technical and public advisory committees. So they were formed shortly after. So roughly, I think September 2018 was our first meeting. And so since then we've met 11 times. The early meetings were focused on developing goals for the process, and then evaluation criteria, and then a long listing of a process for looking at. So first of all, the plan was focused on three primary components. The first and most pressing is the need to resolve the risk of the Willamar Bluffs force main. It's a force main that was installed in the intertidal zone along the bottom of the Balmoral Beach, and it's proved to be very susceptible to wave action from the heavy southeasterlies that hit that section of shoreline. So that's the biggest driver for the process. And the second one is setting the desired level of treatment for our treatment plant. And then lastly, looking at opportunities for further exploiting opportunities for resource recovery. So we currently recover nutrients from the waste stream and market that as a soil amendment product, but there's potentially other ways that we can recover energy or heat. So that's another element of the planning process. So today we're just focused on the conveyance piece, the resolving the environmental risk along Willamar Bluffs. So the process involved, first of all, establishing a long list. So casting the net wide and looking at all possible options for how we can decommission that section of bluffs and plan for the long term, how to get the wastewater from Courtenay and Comox out to the plant. And then through that process and a series of meetings, they worked their way down to a short list, which is where we were at this fall. And then over the last 2 months, so as summarized here on the screen, so on September 28th, the 10th meeting of the TAC PAC, we started the evaluation process of the shortlist, armed with detailed analysis of the three options, which include, each of which include a new sewer line crossing your portion of Area B between, in the Lazo area, Lazo Hill area. Option one would see a trench and cover pipe cut along the road right-of-ways through Area B, the Lazo Hill area. And then options 2 and 3 would look exactly the same. They differ in that the first portion of the force main from Courtenay to Comox would continue to be reused. So not relevant to today's discussion. So for the purposes of discussion today, it's option 1 being the cut and cover, and option 2 and 3 being tunneling through Lazo Hill. So one of the key technical constraints that we wrestled with as we looked at options for getting our wastewater to the plant were that all of the overland options have to deal with the lay of the land. And between Courtenay and Comox and the plant, we've got 2 significant heights of land, and the Comox Hill, so near where Glacier Drive comes into Comox Road, and then Lazo Hill, which peaks at around Butchers, where Butchers and Lazo intersect. And so these options are wrestle with that height of land because it's expensive and it's risky to pump wastewater up and over to such elevation. So I think it's 55 meters elevation at Butchers and Lazo. And that's compared to a maximum elevation of our existing force main of 13 meters. And so that extra elevation translates to much higher pumping costs, much higher pressures in the pipe, and risk at our pump stations in the force main. So that first meeting, we waded through all of that information and got started on the evaluation of those 3 shortlisted options. On September 30th, October 1st, 7th, and 8th, we had a series of public open houses where we heard from the public to understand the public's perspective so that we could feed feedback from the public into the final evaluation of the shortlisted options by the TAC PAC. So that public engagement process ended on October 12th. And the engagement results at a very high level here, we heard from many people that protecting groundwater was a priority and that we should prioritize that when we evaluate the options. We certainly heard that minimizing the costs and the impacts on taxpayers was very important to people, and also minimizing the construction impacts. This is a major project. We're talking about a very large pipe, just under 1 meter in diameter, that will be bisecting the community of Comox, which is where the majority of the construction impact concerns came from. And then we also heard a lot from people who felt that we should we should never put a pipe in the estuary, and that we should, accelerate removal of that pipe from the intertidal zone. Next slide, please. So on October 27th, it was TAC Pack 11, so that was the second of the pair of TAC Pack meetings that were intended to evaluate and select the conveyance solution. So the results of that conversation, that day of discussion, was that the first option was eliminated. So it was fairly far behind in points, but that option 2 and 3 tied. So they, as I mentioned earlier, they are quite similar, but there are some significant differences. The option 2 would see the entire force main replaced with an overland force main, and option 3 would see the portion between Courtenay and Comox retained until the end of its life, and then the remaining portion delivered immediately. So just at a high level, option 1 was penalized for being the most expensive and the highest risk. As I mentioned, that one would involve pumping up and over the full height of land. Option 2 was almost as expensive as option 1, but had a lower risk, so scored better. Option 3 had the least impacts to taxpayers, so scored well from that perspective, but had some elevated risk from continuing to use the foreshore pipe. At the end of the day, option 2 and 3, those key factors effectively balance each other out, and they were tied. So as a result, those staff are tasked with developing a recommendation based on the outcome of the TAC Pack process, the public feedback that has been received, and then putting all of that information in front of the Sewage Commission, which we hope to do in early December of this year for that decision. Just the last point there, just to highlight that both options 2 and 3 look exactly the same to residents of the Lazo Hill area. Just the next slide, please. So there were some questions in advance of the meeting, just regarding the lack of a map for just highlighting the approximate alignment of a tunneled pipe through the Lazo Hill area. And I have to apologize for that. We were quite focused on construction impacts, and the map that explained options 2 and 3 did show the alignment for option 3 running along Lazo Road, when in reality, as this map shows, the exit pit for the tunnel would be near the intersection, or at the intersection, of Balmoral and Torrance, and the entry pit would be about halfway down Moreland Road. So we go to, so it's actually one more thing on this slide. So the technology selected for tunneling through Lazo Hill, if that option is selected, and it certainly looks that way now that option 1 has been removed, is horizontal directional drilling. And I'll get into the details of how that works on a subsequent slide, but what's something to note here on this slide is that yellow line laid down along Balmoral. So just something to keep in mind is that the part of the horizontal directional drilling process is creating a hole, assembling a pipe, and in this case, that would be laid down along Balmoral Avenue with some significant construction risks or construction impacts to the town of Comox. So it takes about 2 months to assemble that pipe while the tunnel is being, that hole is being created, and then that entire assembled pipe would be drawn through the hill, and thereby connecting those two, that entry and exit pit, with an installed pipe. So next slide, please. So horizontal directional drilling, which we refer to as HDD, involves drilling a pilot hole along an alignment. So from an entry pit to an exit pit. So I just saw a question pop up there about what is an entry pit and what is an exit pit. So the entry pit would be where the The drill rig is set up, so it's instead of having like a well drilling setup, point straight down. This is a similar setup, but at an angle that's pointing in the direction that the tunnel will run, and then that drill rig is able to steer the drill bit and follow a precise alignment that's worked out in detail in advance, and surface at the exit pit. So the first step is to drill a pilot hole along that alignment, and then the next step would be to pull progressively larger drill bits, they're called mandrels, to gradually enlarge that hole through progressive passes back and forth along that pilot hole until they've reached the desired diameter. So throughout that process, a slurry, almost like a smoothie consistency material that's composed of bentonite clay, so a very slippery mixture of clay and water, would be pumped through that hole, and that accomplishes three things primarily. It provides some lubrication for the drilling process. It removes the excavated material, because as the drill bit is pushed through that hole, it's creating debris which gets suspended in the slurry. The slurry is being pumped to either end and then processed through a treatment plant. The waste from the largely sand in this case is removed, and then the slurry is pumped back in the hole as recycled. And the third objective of that slurry is that it holds the hole open during this process, preventing the sand from sloughing in. So once the hole is the correct diameter, and the pipe is fully assembled, so in this case laid down along Balmoral Road or Avenue, the pipe is then pulled through the hole and greatly lubricated by that presence of the bentonite slurry in the hole. So it's a very slippery mixture, and for the last little while, as they're waiting to pull the pipe in, that clay material is seeping into the surrounding sand. It penetrates approximately 10 inches and solidifies, and the end result is a very slippery layer on the inside of that sand hole. So the pipe, given the lay of the land and where the entry and exit pit will be, the pipe depth below the surface will be between 5 meters and 30 meters in depth. So obviously 30 meters at below the highest point of land on the hill. Next slide, please, Marcy. This is just a diagram graphically illustrating what I just described. So on the top left, the drilling of the pilot hole, so that you can see the drill bit on the front there is intended to take the first pass. It eats away at the full width of that pilot hole. Once that, and you look at the very top, you can see the drill rig and point. In this case, they're going under a river. In this case, in our case, we'll be going under a hill. So push through to the exit pit, pull the reamer back through. And what it doesn't show here is that for a hole of this diameter, it would take multiple passes, and they'll have multiple diameter of reamers. And then finally, the bottom right, the final reamer is attached to a special fitting on the front of that assembled pipe and drawn through a hill. Next slide, please. So, question that has come up is, so clearly with this option, it does not follow the road right-of-way. So the majority of that alignment would fall under private property, although there are sections of road right-of-way that it crosses. The majority would fall under private landowners. And so there was questions about what would that process look like. So on our end, what we're planning is that after the Sewage Commission decision is made, if they support the direction that involves tunneling under Lazo Hill, we'll be reaching out to property owners along the tunneled alignment to initiate discussions about to work towards establishing a statutory right-of-way. So the alignment that's laid out on the screen here is not set in stone. There is some flexibility. So there is some room for shifting north and south to a limited extent. In terms of the terms of a statutory right-of-way, and most people might be familiar with a typical SRW, which is used for surface pipes, so pipes on the surface. Some of you may have SRWs on your property already. And in that case, for pipes that are installed through trench and cover, it's common to have a restriction on putting fences or structures over top of that alignment, both to avoid the potential of damage to the pipe underneath. Often they'll have language around restricting the growth of trees, that type of thing. So a tunneled alignment SRW is quite different, given that the pipe is so far below the surface. So in a typical SRW, statutory right-of-way, the value, the compensation to the landowner for the SRW is approximately 25% of the footprint that's impacted. So in this case, we're probably looking at a 3-meter width of an SRW crossing the property from one side to the other over top of where the pipe will be installed. So that area, 3 meters wide by X meters long, and then as a fraction of your property value, and then 25% of that value. So that's a rule of thumb for the compensation. And as I mentioned, there are minimal restrictions associated with this type of SRW when compared to an SRW that's typical for a surface pipe. There was a question about how we would prevent the accidental puncturing of such a pipe by drilling of a water well. And that's an example of a restriction that you would see on a tunneled SRW, is that obviously there's no drilling allowed over top of on that SRW. And so, and further to answer that question that was asked, this pipe obviously would be registered with BC1 call. So contractors and who are looking to dig or drill are required to contact BC1 before digging or drilling. Next slide, please. This is a cross section that was shown at the public open houses, that was developed with the help of Gilles Wending, who's on the call today from GW Solutions, who's a hydrogeologist. And so what it shows is the approximate profile. So looking at the side, that cross section showing the height of land on the top. The green squares represent shallow wells that are registered and known. And so those ones would be tapping into superficial type aquifers. So if you look at the kind of the center and right, you can see that there's like a gray band near where those green squares are. And so those shallow wells will be drawing from water that is held up by some type of impermeable layer that's fairly close to the surface. And so rainwater that falls on that aquifer's catchment area pools in those that supported by that impermeable layer, and those residents have shallow wells are drawing water from those superficial aquifers. The whole kind of the bulk of that Lazo Hill is actually composed of sand. It's referred to as the quadra sand, and it's that layer of sand that occurs throughout this part of the coast. And this is a big outcropping of it. This particular outcropping does extend quite far northwest. But so in this case here, so what we're highlighting is that when you get down below that superficial aquifer, it gets into quadra sand, and then within the quadra sand, the groundwater level is quite low down, fairly close to sea level, in fact. And so you can see the pink lines are deeper wells that have been drilled down into to try and tap into that groundwater level. And so Gilles and his team were able to plot that level, that approximate groundwater level based on information that's been registered at the time of the drilling of those deeper wells. And so and then lastly, what I'll point out is that yellow line, the yellow band that crosses the center of that quadrasand section. That's the approximate location of where the tunneled pipe would be pushed through. And so what this highlights is that there's approximately 10 meters gap between where the pipe would be expected to be installed and the top of the groundwater. And I just saw a question pop up, and I'll just answer it now because it's relevant to this. And so I believe the question was, some of these wells appear to show a difference between the appear to be above that groundwater level. And as I think, and I'll maybe I might pass this on to Gilles at the end of the conversation, but I think we all know from speaking with residents in the area that some wells produce better than others, and some wells may not have been down fully into that groundwater level. So next slide, please. So so in terms of what we plan to do to protect groundwater. So in addition to building as robust as possible a piece of infrastructure as we possibly can in compliance with all of the tightest standards, we plan to establish a baseline of water quality and quantity in the area. So this would be something that's crucial to establish, to allow monitoring to take place and compare against that baseline. And then also in the event that residents do feel that either groundwater flow has been impacted or that groundwater quality has been impacted, we have something against which to compare. So that would be the purpose of establishing the baseline. Second of all, we plan to undertake a rigorous third-party review of the preliminary design and assumptions that have been done on the project. So if a tunneled option is selected, this is one of the next steps. So this is typically referred to as a value engineering exercise, where we undertake a moderated process where independent experts in each of the fields that overlap with the scope of the project are pulled from often around the continent into a room, have the opportunity to review all of the project information, and then provide suggestions on how to, well, certainly to if any flags have identified that we've missed, and any improvements to the project to help with controlling risk and cost savings. Third, we plan to build on the work that's the geotechnical work that's been done to date to undertake a very detailed seismic and leak detection assessment, and that would be fed into the design. We would be undertaking groundwater monitoring during construction to ensure that the construction methodology, the installation of the pipe is not impacting groundwater quality. We would be undertaking a high pressure test of the pipe. Once it's finished assembled and laid down on Balmoral, would undergo a high pressure test where the pressure is required to be maintained for a 24-hour period. If not, then every welded joint is then checked again, pressure test ran again, and then again after that pipe is pulled through the hill, another high pressure test. And lastly, we've been putting a lot of effort into researching and looking at opportunities for real-time leak detection. So what we've done locally to date with our existing pipes is undertake a kind of one-off acoustic inspections of our force main to confirm that there isn't a presence of leaks. So that would be, initially that's what we were thinking would be appropriate here, would be to run that acoustic sensor through the pipe on a regular basis, and look for the presence, the telltale acoustic signature, the hissing of even a tiny pinhole leak. but technology has advanced significantly, and we're now aware of some hydrophone technology that can be installed that provides real-time, millisecond response for detection of that acoustic signature of a leak, to ensure that that we're aware of it as soon as it happens and can take corrective action and communication with the local residents. Can we go to the next slide, please? So there was a question about reference projects. I guess implying that potentially that to reassure that, perhaps to reassure that we're not pursuing a type of project here that's cutting edge or overly risky. So we did work with our technical consultants who have been involved in obviously a lot of similar type projects in their careers, and with a focus on projects and situations in our part of the country, in the province. So what they highlighted is that there's a lot of similar HDD projects out there. So there's nothing special or unique about this type of HDD installation, whether it be the diameter, the pipe material, or the geotechnical conditions. We've got a long list of reference projects that we can share if desired, but maybe more targeted at speaking to the concerns here is just highlighting that this list of local Lower Mainland communities all have sewer infrastructure that's above their drinking water aquifers, and not just these highly engineered and pressurized force mains, but extensive collection systems, gravity collection systems, which are notoriously leaky. If you they're bell and spigot joints. The wastewater flows into and out of manholes every 100 or 200 meters, and presenting lots of opportunities for wastewater to leak out. So I think the fact that that these communities are comfortable with with exposure of their drinking water aquifer to a municipal collection, wastewater collection and transmission system is a reflection of the reality of the very significant capacity of the ground to filter wastewater. And that's exactly the mechanism that works for your own septic systems, and is behind the regulations requiring the depth between the septic system drain field and the highest water table. And that's why I focused on that 10-meter gap between where the pipe is anticipated to go and the top of the groundwater, because that 10 meters of highly pressurized and condensed sand would provide significant filtration and attenuation in the very unlikely event of a leak from this pipe. Next slide, please. So kind of touched on a little bit already, but what if there is a leak? So speaking with Gilles, and he can expand on this if desired by any of the attendees, he indicates that we could expect, like I say, in the very highly unlikely event that there is a leak from this pipe, he would expect that it would take weeks, depending on the extent or the size of the leak, it would take from weeks to months for wastewater to get from the pipe through that 10 meters of highly condensed and pressurized sand down into the top of the groundwater. So with the presence of the continuous leak detection technology on the pipe, that would let us know immediately if a leak were to occur, and not only that, but because of the triangulation capabilities of the successive hydrophones, they can very precisely triangulate where the leak is, allowing a focused response for repair. And so what if there's a leak? The CVRD is we're prepared to recommend to the commission that we commit to communicating, even of a possibility of a leak. So whether it's certain or confirmed or not, any suspicion of a leak would be shared, and then monitor for impacts in the surrounding area. Digging down and patching from the exterior because the pipe cannot be taken out of service. And lastly, ensuring safe water supply for any impacted properties. Last slide. So the next steps, so building on what I communicated about our process, our next steps will be to summarize your feedback about any outstanding concerns about groundwater to inform the commission decision, which we expect in early December or January. And subsequent to that decision by the commission, if a tunnel alignment is pursued, then to reach out to the property owners along the tunnel alignment to start the discussions about the statutory right-of-way and also discussing access to wells for sampling of the well water and measuring of the level, so we can start to build that baseline upon which all future monitoring would be based. So that's it from me. And I'll pass it over to Marcy to moderate the questions.
Wonderful. Thank you, Chris. We went through a lot of the topics that have been emailed in, a lot of the questions, and I'm going to loop back to some of the first questions that came in. Chris, I'll let you pass things to Gilles if it's appropriate. So one of the early questions was actually, let's get a quick one out of the way. It was about entry and exit pits. If you can just tell us how big those are typically in size.
Sure. Okay. Yeah. So for example, the entry pit, sorry, I believe it's the exit pit. The exit pit at Balmoral and Torrance would be expected to be located in one lane, 1.5 lanes of that road. So that would be the approximate width, and about twice that in length. So we're looking at approximately 4 or 5 meters by 8 meters in terms of the footprint. And then on one end of that pit would be perched the drill rig. So then extending that total footprint of that. So it's the total footprint would be the size of the pit plus the size of the drill rig, which is located at one end of that pit.
Right. Okay. Moving along, a question about wells. How far from the pipeline was considered in plotting the wells, or are there wells only in the 3 meter of the land allowance? And I'm not sure if I've got the gist of that question right, but it was one of the early questions in the chat that you might, we've got Gilles on call here. If you want to speak to that. I can also go back to some of those slides.
Yeah, I think so. What Gilles and his team did was review all of the registry, so that the cross section showing all the wells corresponds with a kind of a plan view which shows the locations, and so those are known wells that are registered. So there are surely other wells out there that aren't, and so. So when we start to develop, if we go down this route and start to develop a more detailed alignment, there will be work to confirm if there are unknown wells and then how to work around those. And another question that came up in advance, which I can answer now, just is with respect to the minimum distance. So whether the minimum 30-meter distance applies to from a drinking water well applies to this type of pipe. So unfortunately, I don't have a firm answer on you. We've reviewed the regulation with our consultants, and it's not clear that that this pipe. So there's language surrounding 30 meters from a probable source of contamination. Is a pipe engineered to this level a probable source, or not? Less clear. So we do know that we would want to maintain a minimum 10-meter distance from any wells from a construction methodology perspective, to mitigate the risk that any of that bentonite could get into a groundwater well. And then we're still examining the question of whether the 30-meter minimum distance applies. And whatever that answer is, we'll work within that constraint to develop that alignment.
I'm staying just on wells. What about properties that presently don't have a well? How will those interests be protected?
Well, I guess that would be, I guess, part of the negotiation in securing an SRW, is that there would be a requirement to yeah, you know, this is very early days in our thinking about that, but obviously that requirement not to drill a well over top of the SRW proper, but there may be an additional requirement to you know, if the 30-meter minimum stands, or whatever that minimum distance is, that be built into the SRW commitment, that that they not be allowed to install a well within that range.
Okay, a quick question about the pipe before and after the underground portion. People are wondering if it will lie on the surface. Will the pipe block or affect the aquifer in any way? Yeah, I think we covered some wells as part of that question, but yeah, if you can speak
Sure.
to the pipe.
Yeah, no, so the pipe will be cut and cover on either side of this tunnel. So that means digging roughly a 3 to 4 meter deep trench, putting appropriate bedding in, and then laying the pipe down, bedding material over top, and then backfill. And the depth depends on the presence of other utilities, but there's a minimum depth over top of the pipe of about 1.5 meters. And in any area where there is known flow of groundwater, particularly if there is a shallow aquifer with a confined layer fairly close below, then the trench will be built with dams within it, because normally that bedding material is granular and provides a means for groundwater to flow, which we definitely don't want to happen if there is known flow of groundwater in that area, particularly if it's fairly shallow and confined. So there's a very clear methodology to install use clay within the trench at periodic intervals to stop the flow of groundwater along the pipe.
Great. And in terms of that pipe, what is the life expectancy before it could need to be replaced or have maintenance happen? Do you have some timing on?
The pipe has an 80-year life expectancy, but yeah, so I mean, we would expect it to last at least 80 years.
Okay, we're zipping through the questions. There's still lots to come. So we're going to aquifers, Chris. The drinking water aquifers that you refer to in slide 10, are those the very large areas that feed a larger scale of drinking water extraction, or are they more feeding into individual wells that draw from the aquifer?
Well, so the quadra sands, as I mentioned, there is a continuous, there's a large section of the quadra sands within the valley that stretches from the Goose Spit northwest. So there, as far as I know, I mean, it does stretch fairly far, and there's approximately 1,500 or so wells that draw from that unconfined aquifer. So it is a large aquifer. So all of the deep wells in that area on the hill are drawing from that large aquifer.
Okay, I'm going to try and combine some of the questions that are coming in terms of the pipe. Would it affect or limit potential future development above it? And then along with that, if there is a need to repair a leak, is it going to be a big dig up of someone's yard? I think there's a lot of concern about leaks. We've talked about repairing leaks, but maybe you can speak to some of these concerns. Yeah.
Okay, well, I mean, I can't highlight enough how little we would like to be dealing with a leak at any point in the future for this pipe. So, I think, as I highlighted to some people at the open house, I mean, this pipe, similar to our existing pipe, will be our only pipe. So we have every motivation to build this as robustly as possible to avoid the occurrence of a leak. So we feel and strongly supported by our engineering consultants, and hopefully by the value engineering process, that the likelihood of a leak is extremely low. we just to put it in context, we have a 40-year-old pipe that's running, through the intertidal zone that's composed of bell and spigot, steel reinforced concrete pipe that was mowed in the 70s and 80s, which has long since been abandoned. And that pipe has never leaked. What's being considered for installation here is light years ahead of that in terms of technology. The seismic standards to which this pipe will be built compared to what was built 40 years ago have grown exponentially. The design, the seismic design standard requires the pipe be designed to something like a 2,500 year return earthquake, which we focus a lot locally here on the big one, the one that we expect every 300 years that we're quite frightened of. Well, a 2,500 year return earthquake is far larger than the big one, and that's the earthquake that this pipe needs to be designed to. So all of that to say, we're not planning on this pipe leaking. In fact, we're doing everything, we would do everything possible to ensure that never happens. In the extremely unlikely event that it did, the continuous leak detection would pick it up, pinpoint it, and we would have to dig down, expose that section of pipe, and repair it from the outside.
That's great. I think you've answered one of the questions, which was about earthquakes and seismic. I'm going to take a quick deke over to some of the email questions that have come in, and specifically one was about routing. And I'll just present it as it came in. Why has a tunneled route along Balmoral Bluffs or beach not been considered? If you want to switch gears for a minute and talk about that.
Sure. Yeah. So as I mentioned, the LWMP, the TAC-PAC process, the Technical and Public Advisory process, started early on with a long listing process. We cast the net far and wide, looking for all possible options to avoid, getting far into the process and having people say, "Oh, why didn't you think about this?" So the issue with that section of the bluff is its exposure of the beach, is its exposure to the southeasterlies. So so installing a new pipe along that beach, not practical, was not considered. But I understand the thrust of the question that, what if it was put well below ground level and below any risk of exposure from the waves? And so the answer to that is there's a range of answers, but one of them is that would necessarily mean a large dip down. We would start at the Goose Spit, we would end at Curtis Road. And in order to get down deep enough for the erosion not to be a problem, we'd have to go down, and it would create a dip. And operationally for a wastewater system, that is, it's not tolerable. That just acts like a basin for catching grit and other material that settles out from wastewater. So that's one of the big ones. The other one is that it would be entirely underwater. So that is, just because it's underground, if it's below the sea level, that ground is completely saturated. So that would also be a non-starter for the HDD methodology.
Okay, staying on routing just for one more question here. Why was the Area B Moreland Road route chosen rather than using the Comox right-of-way to the west of Lazo?
Sure, yes. That option is now off the table, because I see that it's associated with the option one, so the cut and cover route. But just very, very briefly on why that route was selected. It's the alternate route that was suggested is almost a kilometer longer, and given that the cost of installation are approximately $4,000 or $5,000 per meter. So that does translate to, it's not an insignificant additional cost. So that's on the order of $4 million premium for taking that other route. And like I mentioned, that is associated with option one. Option one has now been taken off the table. That route would not have anything to offer an HDD alignment because of the elevation.
Okay. We're going to change gears again. I see lots of questions in the chat, but I did want to ask one that was submitted by email, and it was specifically about being in touch and working with the Ministry of the Environment and Island Health. So the question is, do either of those groups have sign off on the conveyance design, and how have you been consulting them to date?
Yeah, Island Health will have sign off on the project as a whole. So necessarily that will include the tunnel alignment. So the answer to that is yes. We haven't engaged them to date other than to have, they do have a seat at the table on the TAC pack. So I can't say that they're there every meeting, but they were there at the beginning for the first few meetings, and they receive all of the materials. So they are aware of what's under consideration. Ministry of Environment is also sitting at the table or has a seat at the table at the TAC pack and receives all of the information.
That's great. So looking at the time, we are at the end of our planned hour, but I know that there are lots of questions still coming in and lots still to catch up on. So let's just keep going if we can. For those of you who had only booked an hour for the webinar, feel free to drop off if you need to. Otherwise, please stay on and we'll keep going. Chris, this is valuable time. So I'll go right to the next question. We have a question about the data that's being collected from the monitoring wells in the area. Can you share any of the data, or perhaps you want to take that offline, or is there an online location for some of that data?
No, absolutely. Our intention is to make that publicly available. So we're actually expecting the report summarizing the geotechnical work that was done this summer any day, and our intention is to make that report public after we've gone over it back and forth once or twice with the consultant. So that will be made public and available on our website.
Okay, I'm going to skip over a question about drinking water, fresh water. The quadra sands are extremely permeable. How would a leak not affect the aquifer?
I could take a go at that, but maybe I'll ask Gilles to step in and speak to that one. Gilles, do you mind?
Yes, yes, that's true. The quadra sands are present at several locations along the East Coast, and they are good aquifers because they represent a large mass of sand. But still, they are made of particle of sands which make like the skeleton of the mass, and you have pores between the grain of sands, and this is where the water is stored. So, but even in a good sandy aquifer, the water would take a long time to travel. In a typical sandy aquifer, it will travel, let's say, 300 meters, 500 meters in a year. So this is how slowly the water travel in a sandy aquifer. So in our case, we are considering what would happen, worst case scenario, if there's a leak from the pipe. How would the water move radially and out of the pipe, and what would happen? So it would first fill up all the voids available around the pipe in a bulb shape. So it wouldn't be like a column that would be created that would go straight vertical down to the top of the saturated zone in the quadra sand, which was the water table. So it would be more almost like a spherical volume that would gradually be saturated. So there is first a lot of volume offered by the dry sand, where the liquid waste would start moving. And as the bulb increases in size, the volume increases. And so there would be a little bit of almost like horizontal flow, a little bit of vertical flow, and then it will gradually increase in size, and then until the bottom of it reaches the top of the aquifer or the water table. And so that's why in one of its slides, Chris said it would take weeks to months for that percolation and that migration of the wet front to reach the water table. So there is a lot of time and a lot of more volume considered. Also, that happens, there is reaction, biological reaction that would take place because the unsaturated quartz sand is also full of native bacteria that would degrade the bacteria and the viruses present in the liquid waste. So there would be a filtration effect and a remediation effect that would take place as the wetting phase migrates gradually and vertically through the non-saturated quartz sand. So I know it's a very complex situation, and the pressure in the subsurface at 30 meters, 40 meters depth is function of the weight of the soil from ground surface to that depth, the pressure of the gases, of the oxygen and the air within the voids in the non-saturated sand is also, it's a very complex process. So it would, it's not simple, but it won't take just a few days. It will take a long time before the wet front moves downward and reaches the water table. As I mentioned, there would be also some filtration, some filtration and remediation process that would take place. Okay, so I am seeing a lot of questions around drinking water quality, and I'll just try and bundle a few of them together. So the pipe, would it pierce the aquifer, and would that impact households with shallow wells? I see someone suggesting, would it make more sense to get everyone connected to municipal fresh city water? I don't know if you want to tackle any of those, Chris, but I'm hearing through the chat some questions about drinking water and wells. So, or Gilles, while you're here, do you want to address any of those?
Well, maybe I'll just speak to a couple of those, Marcy. First of all, the puncturing of an aquifer. I think what we've clearly shown here today is that the tunnel, if installed, would be well over top of the deep aquifer that many of the residents in this area draw from. So there's no possibility of that aquifer being punctured. Where that may be more relevant is along moorland. Just thinking back to that cross section where I highlighted the green wells that are drawing from the more shallow aquifers. So very careful additional work will need to be done in that area, particularly well, for the trench section along moorland. But we're also considering a horizontal directional drilled, or HDD, crossing of the Lazo Marsh to minimize impact on that sensitive ecosystem. So the work in that area will need to be very carefully undertaken to ensure that once the project is finished, that there isn't any change to the flow of groundwater in that area of shallow aquifer.
Okay. This is the point where I encourage anyone who hasn't had a chance to ask their question to pop it into the chat, as we are getting close. Well, we've got still some more time. With the previous webinar on the conveyance routes, we did commit to any questions that weren't answered in the webinar. We gathered and we answered them in a Q&A that was posted along with the recording. And so that is the CVRD commitment tonight to do the same. So don't worry if you have questions in the chat that we may not get to time-wise. We will answer them, but I do, just like a live webinar or live open house, we do like to extend the courtesy that everyone has a chance to have questions answered. So let's jump back in, talking about removing the existing pipe off of Balmoral Beach, and what are the risks related to that, and is the CVRD prepared for those?
Sure. So we commissioned a study earlier this year, which is still in draft form, but will be made public, just about that very question about what decommissioning of the existing pipe should look like, or what are the options. And our conclusion from that work is that we'd be very unlikely to remove the pipe from the Balmoral beach, and much more likely to decommission it in place, just because of, that section of beach has been disturbed enough, and it is a perfectly acceptable practice to flush the line and fill it with some type of inert material like sand or a very weak concrete, to render it harmless and to be left in the future. So while there are other sections of the pipe which we will consider removing, that section of along the beach is not one of them.
Okay, a question about something in the past that was under consideration. There was a plan to build a pump station in the Midden Road area and pump over the Lazo Hill with trench and cover. Why was that rejected? Sorry, it was thought to be low risk to groundwater and the best choice. Why reject that very idea as too risky now?
Well, I mean, that project was a very different project, so commonly referred to as the Comox 2 pump station project. So there was several kind of fatal flaws to that concept that emerged as the farther we got into our due diligence on that project, and primarily relating to having another pump station, having both the Courtney and Comox pump stations pump into that station, and then have that pump station pump up and over the hill. So having a new possible point of failure, the impacts on that local neighborhood, and the pressures that pump station would have to pump at to get up and over the hill, which is exactly the type of one of the challenges which I described at the beginning of my presentation that we've wrestled with, and that the committees have wrestled with, is how to get the wastewater over to the plant without having to go up an over 55-meter elevation. So
Okay.
Yeah.
Another question. Someone has had experience with the shallowly buried force main, working with the RD in the past. And the question is, why should landowners have confidence in the RD to work with them in good faith and generosity on this project? If you can speak to some of the plans in place for that.
Oh, it's a tough one to answer. I mean, I think we've made it clear our commitment to build as robust a pipe as possible, and how much our interests align with the interests of those along the pipe route. Our commitment to monitor and respond as quick as humanly possible, and to make good of any impacts and ensure safe access to drinking water. So our intention would be to embed those commitments within the liquid waste management plan, which is a statutory document that is approved, monitored, and enforced by the province. So there's multiple levels there. My own commitment, the future commitment by the commission, and the province enforcement of the plan.
Okay.
Russell here. And I just want to follow up with Chris's comments on that and say to everybody online that we have made mistakes in the past, but we have learned from those. And we certainly are under a far different criteria in terms of planning and developing projects like this. And the layers of scrutiny and consideration that are being given by having a technical advisory committee, a public advisory committee at the liquid waste management plan to review every option available and to help us to make these decisions. These are decisions that are being made in the open with lots of technical and public support, and decisions that are being made with transparency. It really is our commitment to listen to you, the people of Lazo. We know that groundwater is important. Conducting this meeting tonight and hearing all your input so that we can present a plan to monitor, plan, design, and install something that is the best possible solution for everyone. is foremost on our mind. So we really appreciate all the tough questions we're getting here. I just want to assure you at every single level of this organization, we are committed to doing this right.
Thanks, Russell, for chiming in there. That's great. I'm going to jump back into the chat questions, as well as I've got some from email that are all sort of on the same theme. And it's going back to leaks and testing and how quickly a leak would be located, the leak detection equipment, how often does that need to be replaced? I'm hearing a lot of questions or seeing a lot of questions about finding and repairing leaks in the pipeline that's quite deep underground, and can the flow of sewage be stopped quickly? Can you speak to some of the technology that's available these days to address some of these concerns?
Yeah, I mean, I feel like I've spoken a fair bit about that already. That you know, we currently use acoustic technology that's sent through the pipe, but that we're now aware of technology that can be installed at the time of installation of the pipe that can, instead of monitoring on a regular basis, monitors in real time. And that technology allows the pinpointing of that acoustic signature. So, I mean, first, it's important to understand that a leak in a pressurized pipe has a very loud acoustic signature. It's a hiss. As you can imagine, it's underwater, and even the tiniest pinhole, with high pressure water pushing through it, will make a very recognizable acoustic signature. And so actually I've got, here's this, this is the casing for a smart ball. So there's a very dense piece of high-tech equipment that gets subbed into the middle of this squishy ball, and then gets sent down the force main, and it's listening very carefully for that acoustic signature. And then there's sensors on the outside of the pipe that allow it to triangulate its location. After that, it outputs a graph, and we haven't seen it on our own pipes, but we've looked at data from others that show it's a very clear acoustic signature. So these new real-time monitoring devices make use of that similar type of acoustic sensors, but they have them hardwired and installed in the pipe, and then they're listening for that sound. So if you've got one every several hundred meters, and then two pick up a sound, a very recognizable sound of a leak between themselves, and then you instantly compare the intensity, and then you determine where that sound is coming from between those two sensors, and then that all happens in real time. An alarm is sent out, the data is reviewed, the sensors are checked, and as I mentioned in the presentation, there'd be a protocol in place for notification, monitoring would start, and planning for how to fix that leak. Again, I have to reiterate though that it behooves us to put in as much effort and expense on the front end to avoid that from ever happening, because I think I heard you, Marcy, say at the end there that is there the potential of shutting off the pipe, and the answer to that is really no. This will be the only pipe as we only have a single pipe now, so there is no redundancy. So to me, that just highlights how critical it is that this pipe be installed as robustly as possible, and that should provide comfort.
Okay, we'll take a quick break from leaks, and just a question about routing. One of the conveyance routes posted on the website appears to travel along the road allowance along Balmoral Road, and down Moreland Road. But tonight in the map, it shows traveling a different route through private property. And I can pull up the slides if you need.
I think I can speak briefly to that. As I mentioned at the beginning of the presentation, the public engagement material is focused on construction impacts, and for that section between Torrance and Moreland, instead of showing the direct alignment, the HDD alignment, it showed the alignment along the roads, just to highlight, because it's comparing it to the other option where there is road impacts, so high road impacts along Lazo for options 2 and 3. It's low because the pipe doesn't follow it. It actually follows a different alignment. So I provided the map in the presentation. We will share this presentation. I'm not sure whether we'll do that through the website. Yeah, so that will be available for residents.
I'm just going to go to that now, or I'll just mention, let's get there here. We are going to be posting the presentation as it's been recorded, as well as the answers to some of the questions, because I don't think we are going to get to them all. We've gone over a fair bit, and there's still lots of good questions in the queue. So I'm going to put up a screen that will show you exactly where to find this webinar and the questions. So we've got connectcvrd.ca/LWMP. I hope you can see that. There's also the engineering services email and the phone number. So I know some of you may actually be wondering about your own properties on the route, and I urge you to get in touch with the Comox Valley Regional District if you have property-specific questions that haven't been answered tonight. Did that website? No, that didn't show up. Sorry about that. Let's try one more time. There we go. Here we go. That's better. So there's the website there with the link, connectcvrd.ca, LWMP. That's where all the project information is. And there's the email. Sorry, thank you. There's the email, there's the phone number. Do get in touch. We are recording all of the questions in the chat that haven't yet been answered, and we'll be answering those and posting those with this recording on the website in the next few days, as we did with the first webinar that covered the different conveyance routes that were being considered. So I think we are going to wrap it up here, and thank you all for joining us tonight. Your time is very valuable. I hope many of your questions have been answered. I'm sorry we didn't get through all of them, but we are committed, the CVRD is committed to making sure your questions are answered. I will mention that tonight, this webinar, it is forming part of the official engagement record for the project that will be considered by the Sewage Commission. So all of this input, feedback, questions, concerns, issues has been recorded and will form part of the engagement record to be considered as this project moves along. So with that, I thank you all for being here, spending your time, and I will close off wishing you a good evening. Thank you, Chris, for presenting. Thank you, CVRD staff, for being here. Thank you to all of you who joined us tonight for this information.